Hello, friends and neighbors. Hey, it's Friday, and I'm in the mood for a networking video. How about you? So last week I got into a mood to talk a little bit about flows and what they were about, because I'm thinking more and more about SDN these days. And in my classes, we were doing policies and things like this to do a little control of traffic. So over the course of the week, I started thinking about what else I might talk to you about with regard to flows. So a funny thing happened in one of my classes. A student actually asked me if I was making this up, if this was a real thing, or if it was just a thing that I wanted to, or a way that I used to think about things. And it turns out that it's a real thing. So north-south flows, east-west flows, and the idea of flows in general. So it turns out that flows have been a concern for a long time, as we'll see here in just a minute. But more than that, knowing something about flows on your network or how things are moving can really help you with your network designs. It becomes really, really important when you're trying to decide how to build things that you know where the traffic is going. And when we start thinking about SDN, we realize that one of the promises of SDN was that you could look into the network, see what's happening, and then make dynamic changes or have the network make changes all by itself based on traffic that was occurring or patterns that were occurring on the network. And so the idea is that SDN topologies could somehow see more than traditional or standard network topologies. So here's an example. It's a little tough to see, but what you're looking at here is flows. So this is information that is coming from an OpenFlow enabled device that describes things that are happening on the network at this particular moment. Now, if you look hard, I'm not going to ask you to obviously look at each individual field, but you can see that we've got a number of packets that are identified, the type of packet, the amount of data in terms of bytes, source and destination MAC addresses, source and destination IP addresses, and things of this sort. So it's not just that I know the source IP address and the destination IP address, but I know more about a collection of packets that are heading into the network or going across the network. So here's a little easier way of looking at it. This is actually a flow table from an SDN network element. And as you look across these, you can see that they're not about any particular packet in and by itself. These are the beginning of flow table entries, or flow table entries that are created at the beginning of a flow. So you can see there's a duration associated with them, how long this particular flow is allowed to live. These are brandy new entries, so the number of packets is really low, but the size of the packets, source and destination MAC address, source and destination IP address. So again, this particular network element knows a lot more about, or is keeping track of, a lot more information rather than just, I got this IP address in a packet, where am I supposed to send it? All right, so you might be thinking to yourself, wow, that seems like a lot of data, and it's true, each individual flow entry has a lot of entries. There are 19 to 20 fields just to get started. But on top of that, if you start to consider all the flows that might be coming from a particular node, and then all the different nodes that might be on the network, well, the number of states that we have to remember gets pretty large. And so on large topologies, when we want to look at this, it would become really cumbersome to do that. We'd have to have some analytics help or something of that sort. So there are specifications that describe how to look at the data without looking at all the data. And the most famous is probably Netflow. And the idea is that you take a sampling of the flows, sampling of information about the flows, and then you store that off of a particular router. So the router collects the data and then sends it off. And so we take this data and then we use that as feedback into our processes. And you can see the list. This is a quote right from the RFC. And you can see that it dates from 2004. So it's not a new idea. The idea of flows and flow information has been around for decades. So again, the basic idea here is that routers will collect flow data. And usually, again, it's just a sampling, so they don't know every single flow, but over time you develop a picture of the traffic that's flowing across the network, at least through that particular network element. So a router will specify an interface that it wants to collect flow data on and then send that information to a flow collector. And then the idea of the flow collector is that it processes the data and then displays the information in a way that's useful. Again, hopefully. So you decide a lot of times the metrics, you decide what you want to collect, and the data is only as good as the stuff you collected or the way that you choose to represent it. All right, and this is just a graphic. This is from Cisco, and you can see the kinds of things that are collected with Netflow data. And so you get a Netflow packet from a router, and then that goes to the collector. So this is just another way to look at that particular process. So again, the traffic in this case represents many, many different flows, and then periodically the router grabs the information that it has, sends that in packetized form to the collector. Here's an example of Netflow in packetized format. You can see that we've got flow IDs associated with this, so you can tie different Netflow packets together. And then, of course, there's the data about the flow itself, the source and destination IP addresses, the amount of traffic or the amount of data that's in this particular thing, how long ago we saw it, things of that sort. But Netflow is not the only one out there. Let's not forget some of the other fabulous RFCs that we see in this space. So 711 here, or 7011, is IP flow information, or IP fix. And that set of RFCs has been updated in 2013. And then 3176 dates from 2001. And then, of course, everybody plays in this space. So vendors have their own. Netflow came out of Cisco. It's not a Cisco thing anymore. It's standardized in an RFC. And, of course, Juniper has JFlow. Now, this is just a sampling of the RFCs. There are lots and lots of RFCs that go along with this to support either the architecture or the structure of the data, things of that sort. But this will certainly get you started if you're really jazzed about this particular topic. Well, I think that'll do it for today. Thanks for watching. Thanks for listening. I'm not sure what I'm going to do next. Flow data was sort of something I was in the mood to do, and you just never know what we'll talk about next time. So again, this was flow data on networks, whether you knew it was there or not. Again, thanks for watching. Thanks for listening. May your packets always reach their destinations. And hey, what the heck? This is networking. You can do this.